Welcome to session 4 of Cloud Wrangling with Brian White. In this one, we're going to go over storage and storage networking. The first thing you might be asking yourself is, who cares? Does networking still matter? Does storage networking matter now that everything is in the cloud or software defined? Um, that's a good question. I've actually had this posited to me out in the wild, and let's go over it. I've actually had people ask me, does storage networking still matter in the cloud era? And we'll go through it, but I would say that it definitely does. It matters that whether you're on-prem in your data center or if you're in a hyperscaler, that you have the correct solutions for your needs. And you can see some real weird issues when you don't have everything aligned. When does storage networking not matter? These two use cases are the ones that come to mind. Uh, When you're running bare metal servers with locally attached disk, this would be direct attached storage in servers in your data center. This would be instance store volumes on your AWS instances or Azure Ephemeral OS drives on your Azure instances. At that point, it's all within the server. There is no external storage networking, so storage networking doesn't matter. Same thing if you're running a local Proxmox or VMware server and you're running all local disk, or it's a container node that isn't running Longhorn or any kind of scale out software defined storage, and then storage networking doesn't matter because you don't have any storage networking. It's all within the server. It's all within your PCI bus. You're good to go. When does it matter? Basically, every other time. So every other time that you're running a compute node um, that doesn't just have local disks on it, storage networking is going to matter. So in your data center, in your private cloud, you're going to have bare metal servers that are either going to have IP-based storage networking, whether it be um, SAN over iSCSI, SAN over fiber channel, NFS mounts, S3 compliant storage, or other object storage mounts. If the disks aren't directly in the server, then you're going to have storage networking. And that's true whether you're in your data center or you're in AWS and you're using EBS volumes, or you're using Azure disk storage, or you're using an Elastic file service like EFS or S3, or you're using Azure Files or Azure Blobs, you're still dealing with storage networking because you're still attaching to storage over a network. The standard pattern for SAN in your data center, if you haven't been running in data centers for a while, this is a little reminder, is typically you'll have an IP-based network on the front end, or you'll have maybe two 10 gig ports and a lag and LACP, or maybe two separate ports, or maybe you're running 25 gig networking and you've got 50 gig or whatever you've got. And then usually you'll have a host base adapter that's running something like 32 gig fiber channel storage networking in the back end. Maybe it's 16, maybe it's 64, maybe you're running 100 gig IP and you're running iSCSI, but you're attaching to a storage array volume that these days is more likely than not NVMe, could be SSD, and you're connecting over that SAN, that storage area network. That's what most people are used to calling SAN. And so when you hear the word SAN, a lot of people think legacy, they think data center, but the reality is if you're attaching to anything called block anything, you're going over a SAN. Whether you're in Azure or you're in GCP, you're in AWS, you're attaching to the newest, latest, and greatest IO2 Block Express or whatever the most recent high performance storage is in the hyperscalers, you are attaching to a SAN volume over a SAN network. And this shows you the two most common patterns for network attached volumes within the hyperscale cloud. We're picking on AWS here, but this could just as easily be GCP, Azure, Oracle Cloud, any of the other large ones. So at the top, you have kind of your standard general purpose instance, whether it be bare metal or a virtual instance that has just the standard host networking, whether it be a 10 gig lag or a 25 gig lag or 50 gig or whatever the host networking is without any separate storage networking. And you're connecting to either something like a general purpose EBS block volume, a blob volume, and S3 bucket, an NFS mount, something of that nature, over your standard networking interfaces. And then at the bottom, you have a storage optimized instance that would have in AWS terms a dedicated ENA or EFA um, uh, PCI optimized storage lag that would allow you to uncork the performance of things like their higher end IO2 block express volumes. Um, the benefits of this are that it will allow you to fully leverage the storage uh, platform that you're accessing, whereas you may be getting a lower performance out of the actual storage you're accessing over the network because you are throttling at the network layer. But why do you care, right? Where can this go wrong? Where it can go wrong is take the example of this bare metal instance that's here in the middle that's running a DB software. You have somebody kicks off a very large table scan of the large database that's running on this EBS volume, and it saturates the NICs of that instance um, because of the amount of data that's coming back from this massive table scan. Well, you're going to have two things that are going to happen. You're both going to have reduced I/O performance and slow access, returning that data from that database that's stored on the external storage. But you also are going to start to have front end request stalling, and you're also going to have front end performance because you're using the same network. So this is where converged networking can really get you sideways in both the cloud as well as in your on-prem environment. So some common symptoms of just general poor storage networking is transient or sustained I/O latency. So latency tends to be the most common and most current and most obvious symptom of poor storage networking. Um, you have underperforming applications that are database or I/O centric. You have sluggish I/O performance during peak periods when usage is the highest, and that's when you're saturating your storage networking. You have high errors on your storage fabric. You have particularly angry DBAs because they tend to be angry anyway, but if your I/O performance is poor, you're going to have extra angry DBAs. And then the absolute worst thing that you can have in a data environment and a data fabric is data corruption, which is highly increased if you have an over leveraged or congested data fabric. Common symptoms of poor converged networking performance. This is where things can really get insidious, as if you do have I/O workloads, storage workloads that are running across a converged fabric. It gets very difficult to troubleshoot. You end up with things like intermittent network spikes that affect your entire stack that are caused by kind of your high throughput backend applications. You get weird transient I/O latency that could be caused either by front end API storms or backend I/O saturation, random API timeouts through your stacks, weird issues that you just can't isolate. You get underperforming applications, you get underperforming compute instances where you're kind of not getting the performance you were promised on the 10. Because you have high CPUs that are not able to really do their processing because they're corking in the back end on the networking storage networking stack. You get sluggish application performance across your stack at peak, high errors in general, and just general malaise in your stack. It's really a difficult troubleshoot at times if you do have these kinds of issues. Why it's generally best practice to separate your storage and general purpose networking. But what about HCI, you ask? If you converge everything together, then you won't have any of these problems because everything will be software defined, everything will be running smoothly. Um, it's just metal boxes and wires, right? So HCI will make everything better, right? No, actually, HCI with converged networking can get way, way, way worse. The problem with the hyperconverged model is that if you're not running dedicated storage networking, you are running a storage network cluster node on every single bare metal box in your HCI cluster, which means if you have an issue where you saturate your storage networking, you could potentially saturate the storage networking links to every one of your storage nodes, which would be every one of your compute nodes. So then you start not only having issues with storage performance, you would also start having issues with general purpose compute performance. So having an improperly architected storage network in HCI is actually a really bad problem. And and pretty common. The challenge with HCI solutions is a lot of them are designed for smaller robo and kind of small enterprise solutions. And a lot of those solutions sometimes can, as your environment gets larger, as your business grows, can grow outside of the original specs of the hardware and the infrastructure that was implemented. And you start to see these issues where, when you're running your accounting program backups or whatever, you start to see poor performance on your front end um, billing applications or something like that, where you can see in this instance, your database software is connecting to database instances that are spread across the other nodes of the cluster, and when it does, it starts to downshift because it's slowed down, and then the access from other applications into that software package start to downshift, and all the east-west traffic starts to downshift and slow down and get clogged up. And yeah, HCI is a place where you really don't want to skimp on both your just general purpose east-west networking throughput as well as your dedicated storage network, because it's a place where you can really get a lot of bang for the buck as far as out of your infrastructure, but you need to architect it in such a way that you're really using the whole buffalo. So how do you get out of this ditch? What's the best practice? Run a larger than you think you need dedicated backend storage network, which allows for all those bursts in IO. It allows for all that um, table scans and all the code that we say that we don't do that we know that we do, all the applications that run BI and run all the things. It allows that access to all the disks in that HCI storage cluster and still allows you to have enough bandwidth on the front side to access your applications. So that's the long and short of it. So even in the cloud, storage networking matters. So yeah, storage networking, it matters. It matters if you're in your own cloud, if you're in the hybrid cloud, or if you're in the public cloud, whichever cloud you're in. If you're using it, storage networking matters. Thanks, everybody. Have a great one.